Hello everybody and welcome to Bash Course Quarantine Physics. My name is Young Hank and today we're going to learn about momentum and collisions. Momentum, or more specifically linear momentum, is a property of an object that describes the velocity of its center of mass. It acts in the direction of an object's velocity, and its symbol is a small p, which is equal to mass times velocity. Thus, it is units of kilograms times meters per second. Now that you know what momentum is, let's talk about the change in momentum called impulse. It's also a vector and is equal to force exerted on an object multiplied by the time it takes to exert the force. Its units are newton seconds or kilogram meters per second. You can also find impulse as the area under the curve of a force versus time graph. Another form of impulse equation is delta p equals mass times change in velocity. There's also something called the impulse momentum theorem. It says that impulse applied changes the momentum of an object. However, their final velocities will be different based on their masses. Kind of obvious, I know, but if you kick a soccer ball, it's going to move much faster than if you kick a bowling ball. This theorem also explains why you can stop the motion of an egg you've thrown without breaking it by throwing it at a sheet, but not if you throw it at a wall. Since impulse is force times time, the same impulse, changing the egg from its initial velocity to zero velocity, can exert different forces. Since the time of impact is much greater with the sheet, the force is much smaller than in the short impact against the wall, where the force is large and the egg breaks. We're going to start talking about collisions, but before we do, we need to discuss the law of conservation of momentum, because that is the key to all collisions. The law simply states that in a closed system, total momentum is conserved. Within a system, collisions or transfers of momentum and energy can occur, and as we've just learned, momentum will be conserved, allowing us to make calculations. However, remember that this only applies for closed systems. If an external force is exerted, total momentum can change. In collisions, the forces between the objects are necessarily equal and opposite, and the times are the same, so the changes in momentum of the objects are the same. There are two main types of collisions, elastic and inelastic. For elastic collisions, the equation is m1v1 plus m2v2 equals m1v1 prime plus m2v2 prime. Total momentum is conserved, as is total kinetic energy, and the objects will bounce off each other after they collide without any energy being lost to deformation, sound, or heat. For inelastic collisions, total momentum is conserved, but total kinetic energy is not. In a subset of these collisions, the objects will stick together after the collision. The equation for this is m1v1 plus m2v2 equals m1 plus m2 in parentheses times v prime. These are called perfectly or completely inelastic collisions. They can also be considered in terms of something being blown apart or objects separating. But sticking together is not what defines an inelastic collision, and it's not required for that classification. Inelastic means kinetic energy is not conserved, not necessarily that things stick. The Ke is converted to thermal energy or sometimes potential energy. Great, let's do an example. Alright, say you have a 3 kilogram ball moving at 6 meters per second and a 7 kilogram ball moving at 2 meters per second. Alright, that's our setup. Those are our givens. Alright. After the collision, the 3 kilogram ball is moving at 3 meters per second in the opposite direction it started in. And we're trying to figure out what is the velocity, so magnitude and direction, of the 7 kilogram ball after the collision. Alright? So the way we're going to set this up is we know that there's conservation of momentum. So we have m1 v1 plus m2 v2 equals m1 v1 prime, which is this velocity. It's the velocity after the collision for the first ball, and m2 v2 prime. Alright, now we can start subbing stuff in. We're going to do 3 kilograms times 6 meters per second plus 7 kilograms times 2 meters per second. Except remember that this one's going the other direction, so the velocity is actually negative, so this is going to be a negative. Okay? And then we also know that the 3 kilogram ball we're going to put a -3 right in there. We know our second mass, 7 kilograms, and what we're trying to find is V2 prime. Alright, so now let's do some basic algebra and figure out the answer. So 3 times 6 is 18, minus 7 times 2, that's another 14. This together is 4, right? And this is -9, and we're going to bring that to the other side, so plus 9 over here. It's going to give us 13, and that's going to be equal to our 7v2 prime. Alright, so then we will divide by 7 on both sides, and we will get 13 over 7 equals v2 prime. It happens to be 1.857, and we know it's a velocity, so our units are meters per second. And there you go, we figured out the missing velocity of the 7 kilogram ball. 1.857 meters per second. Thank you all for watching Bash Course Quarantine Physics, and I'll see you again next time. Stay out of school, kids. The Bash Course Quarantine is Sam, Mencimer, Estela, Millan, Eamon, Pasha, Ishaq, Orozco, and myself. Please put any questions you have in the comments below, and we'll do our best to answer them or find someone who can. And as they say in my hometown, oh my EOSH.